Good morning, students. Today we are going to continue with implicit functions and then we'll do differentiation using logarithms. So first question is, if sine y is equals to x sine a plus y, show that dy by dx is equals to sine square a plus y upon sine a. You see, this is very important question. After every alternate years, this is repeated in board exams. So what we do, it is difficult, it will be complicated to differentiate directly. So what we do, we separate the variables. We find x is equals to sine y upon sine a plus y. Now using division rule, we'll differentiate with respect to y. We'll differentiate with respect to y. That is, we'll find dx upon dy using division rule. Dx upon dy is equals to denominator into derivative of numerator minus numerator into derivative of denominator upon square of denominator. So this is dx upon dy. Now dx upon dy, this is sine a plus y. So you are getting finally, this is sine a cos b minus cos a sine b. So this is sine a minus b. So you are getting sine a upon sine square a plus y. Now this is dx upon dy, reciprocate this, so you will get dy by dx. This is dy by dx sine square a plus y upon sine a. So you have proved it. In this question, if you have started with this directly, this was a difficult question, complicated question. But if you separate this, you find dx upon dy, it becomes very easy. Just apply the division rule. Next is, if e raised to the power x plus e raised to the power y is equals to e raised to the power x plus y, find dy by dx. So e raised to the power x plus e raised to the power y is equals to, this is x plus y. So according to law of exponents, this is e raised to the power x into e raised to the power y. Now divide this and separate this. So e raised to the power x upon e raised to the power x into y plus e raised to the power y into e raised to the power x into e raised to the power y. So here you get e raised to the power minus y. This is 1 upon e raised to the power y. And this is 1 upon e raised to the power x. Now differentiate this. E raised to the power minus y into, because we are having y here, so dy by dx, plus e raised to the power minus x into derivative of minus x is minus 1. And on this side we are having 1, so this is equal to 0. So dy by dx is e raised to the power minus x minus e raised to the power minus x upon e raised to the power minus y. So this is e raised to the power minus e raised to the power y minus x. So you see, we are using simple tricks to differentiate the implicit function. This is again the same type of question. If cos x plus y is equals to y into sin x, find dy by dx. Here we will differentiate this, both sides. If cos x plus y, differentiate, this is minus sin x plus y, and then derivative of x plus y is 1 plus dy by dx is equals to, product rule here, y cos x plus sin x into dy by dx. First function into derivative of second plus second function into derivative of first. And now bring dy by dx, terms containing dy by dx on one side and separate them. So this is x plus y plus sin x, dy by dx is equals to sin x plus y cos x. So dy by dx is minus sin x plus y cos x upon sin x plus y plus sin x. So this is how we differentiate. Next is, if y is equals to tan inverse x square minus y square upon x square plus y square is equals to a. Show that dy by dx is equals to x upon y upon 1 minus tan a upon 1 plus tan a. Tan inverse x square minus y square upon x is equals to a. So x square minus y square, this implies that x square minus y square upon x square plus y square is equals to tan a. And x square minus y square is equals to x square plus y square into tan a. Cross multiply this. Now differentiate both sides. 2x, this is 2x minus 2y dy by dx is equals to tan a is constant. This is 2x plus 2y dy by dx. Now take the terms containing dy by dx on one side. Take the terms containing dy by dx on one side. So this is x into 1 minus tan a. This is 1 plus tan a dy by dx is equals to x into 1 minus tan a. So dy by dx is x upon y, 1 minus tan a upon 1 plus tan a. So wherever you get y, differentiate it with respect to x, dy by dx. Now comes differentiation using logarithms. Before that, let's revise this. Laws of logarithm. We have done this in class. Log m into n is log m plus log n. Log m upon n is log m minus log n. Log m raised to the power n is n log m. And log e at base e is 1. Log 10 at base 10 is 1. Log x at base x is 1. Log 10 is 1. So these are the simple rules that we did in class previously. We are going to use this for differentiation. So when do we use this? For which type of functions we use the differentiation using logarithms? So when the given function is a power of some expression, algebraic trigonometric expression, not exponent of real number or like that, or product of expressions, a long product is given, then we differentiate using logarithms. For example, we are taking y is equals to x raised to the power sine x. You see, this algebraic expression and exponent is also an expression. So what we do, we take log on both sides. Log y is equals to log x raised to the power sine x. So this becomes log y using the rule log m raised to the power n is equals to n log m. We have sine x log x. Now you see this part is reduced to product form. Now differentiate both sides. This is 1 upon y dy by dx is equals to, here we are going to apply the product rule. This is first function into derivative of second, sine x into 1 upon x plus second function into derivative of first. So this is differentiated. Now this is on this side, this is 1 upon y, and because we are differentiating y, so this is dy by dx. Keeping dy by dx on this side, cross multiply y to this side. So dy by dx is y into sine x upon x plus cos x log x. Now substitute for y. What is y? X raised to the power sine x. So finally this is dy by dx is equals to x raised to the power sine x into sine x upon x plus cos x log x and bracket closed. Suppose the function is y is equals to x raised to the power x. Taking log on both sides, log y is equals to log x raised to the power x. So this becomes x log x. Differentiate. 1 upon y dy by dx is equals to first function into derivative of second plus second function into derivative of first. This is cancelled. So dy by dx, y 1 upon y dy by dx is equals to 1 plus log x. So dy by dx, cross multiply y to this side. Dy by dx is y into 1 plus log x. Same thing we are going to apply for all the questions. Now here you see we have got product of three functions, and rather here we are having function of a function. First function, second function, third function. It is difficult to apply, not difficult, it is complicated to apply product rule here, product rule and chain rule, then finding dy by dx, but logarithmic differentiation makes it easier. So again we are taking log on both sides. So log y is log e raised to the power x cos cube x sin square x. So log y is, now this will reduce to sum, log e raised to the power x plus log cos cube x plus log sin square x. Again log, this is x log e plus 3 log cos x plus 2 log sin x. Now differentiate both sides. This is 1 upon y dy by dx is equals to 1. Here we are going to, this is x, so derivative is 1. This is 3 log cos x, so 3 is constant. Log cos x is 1 upon cos x, and derivative of cos x is minus sin x plus 2 log sin x. So 2 is constant, log sin x is 1 upon sin x into cos x. So finally this is 1 upon y dy by dx is equals to 1 minus 3 tan x plus 2 cot x. Cross multiply y to this side. So this is now dy by dx is equals to e raised to the power y into, this is y, into 1 minus 3 tan x plus 2 cot x. Now you see here we have, in this question, we have product of 4 functions. So applying directly, it is difficult. So what we do, we take log on both sides. Y is equals to log tan x, tan 2x, tan 3x, tan 4x. So this becomes log tan x plus log tan 2x plus log tan 3x plus log tan 4x. Differentiate. 1 upon y dy by dx is equals to log tan x is 1 upon tan x, and derivative of tan x is sec square x, plus log tan 2x is, derivative is 1 upon tan 2x, and derivative of tan 2x is 2 sec square 2x. This is 1 upon 3 sec square x upon tan 3x plus 4 sec square 4x upon tan 4x. So this is tan x, this is sec square upon tan x plus 2 sec square upon tan 2x plus 3 sec square upon tan 3x plus 4 sec square 4x upon 4. And now bring y to this side and substitute for y. Put the value of y there, you will get the derivative. Next is 2x plus 3 raised to the power 3x minus 5. Y is equals to, taking log on both sides, log y is equals to log 2x plus 3 raised to the power 3x minus 5. So log y is 3x minus 5. Log m raised to the power n is n log m. So log y is equals to 3x minus 5 into log 2x plus 3. Differentiate. 1 upon y dy by dx is equals to 3x minus 5 into first function into derivative of second, that is 1 upon 2x plus 3 into 2. Derivative of 2x plus 3 is 2. Plus second function into derivative of first. So this is dy by dx cross multiply y is equals to 2 into 3x minus 5 upon 2x plus 3 plus 3 log 2x plus 3. Substitute for y. Next is log 5 raised to the power x upon x raised to the power 5. Very easy question. Take log on both sides. So log y is log 5 raised to the power x upon x raised to the power 5. Log y is log 5 raised to the power x minus log x raised to the power 5. 1 upon differentiate 1 upon y dy by dx is equals to x log 5 minus 5 log x. 1 upon y dy by dx. First function, this is constant and derivative of x is 1. Minus, this is 5 log x, so this is 5 upon x. And now cross multiply y to this side. This is log 5 minus 5 upon x. Next is y is equals to sin x raised to the power x. Take log on both sides. So log y is equals to log sin x raised to the power x. Now differentiate both sides. 1 upon y dy by dx is equals to x log sin x. Now apply product rule here. 1 upon y dy by dx is equals to first function into derivative of second. That is derivative of log sin x is 1 upon sin x and derivative of sin x is cos x plus log sin x. And now cross multiply y here. So dy by dx is y into x cot x plus log sin x. And now put substitute for y. Next is y is equals to x raised to the power sin inverse x. Again the same process. Take log on both sides. Log y is equals to log x raised to the power sin inverse x. So differentiate. First take log. So log y is log x raised to the power sin inverse x. So log y is sin inverse x into log x. 1 upon y dy by dx is equals to first function, that is sin inverse x into derivative of second, that is 1 upon x, plus second function into derivative of first, and then again cross multiply y to this side. So this is x raised to the power sin inverse x into sin inverse x upon x plus log x upon root 1 minus x square. Same type of question here also. Y is equals to sin x raised to the power log x. Take log on both sides. So log y is log sin x raised to the power log x. Log y is log x into log sin x. We are using log m raised to the power n is equals to n log m. Now differentiate. This is 1 upon y dy by dx is equals to first function into derivative of second. This is 1 log sin x. 1 upon sin x into derivative of sin x is cos x plus second function into derivative of first. Second function is log sin x and derivative of log x is 1 upon x. So finally this is y is equals dy by dx is equals to y into log x cot x plus log sin x upon x. And now cross multiply y. So this is sin x raised to the power log cos x. Log x. Next is y is equals to x raised to the power x sine inverse root x. You see here we are having product of two functions. So take log y is equals to log x raised to the power x into sine inverse root x. Log y is log x raised to the power x plus log m into n is log m plus log n, like this. And now this is differentiate. 1 upon y dy by dx is equals to x log cos x plus log sine inverse root x. 1 upon y dy by dx is first function into derivative of second, that is x upon x, plus second function into derivative of first, this is 1, plus log sine inverse root x, derivative is 1 upon sine inverse root x into derivative of sine inverse root x, that is 1 upon root 1 minus x square, root x square is x, into derivative of root x, that is 1 upon 2 root x. So y is dy by dx cross multiply y is 1 plus log x plus 1 upon 2 root x sine inverse root x into 1 upon root 1 minus root x. So you see we are using logarithms to make the differentiation to easier side. In next class, we'll take some different type of problems using logarithms to differentiate using logarithms. Do all these questions in your classwork copy and the NCERT book. Whenever the school reopens, your copies will be checked within 1 or 2 days. So complete your work thoroughly and take these classes very seriously. Again and again I am telling, because nothing is clear about your board exams. So be very serious. Thank you.